In today's lesson, we'll be talking about symbolic permissions, numeric permissions, file versus directory permissions, and how to change permissions, how to work with the group file creation mask. As I mentioned in previous videos, when we run ls-l command, it will display the detailed information about the files or directories. If you look at this permissions, the first character hyphen represents the regular file. If hyphen starts with D, then it is a directory. Instead of hyphen, if we see L, then it's a symbolic link. And the other characters are W and we have X also. These these are the main types of permissions. R represents read, W represents write, and X represents execute. If you have R permission, means read permission to a file, that means you will be able to see the contents exist in the file. If you have write permissions to a file, you can modify it, you can change whatever you can as per your requirements. If you have execute permissions, you can you can run that file as a program. Read, write, and execute are fairly self-explanatory when they are applied to files. However, they have a slight different meaning when they are applied to directories. For example, when read permissions are applied to a directory, that means you can see the files in the directory. If you don't have read permissions to a directory, you will not able to see the directory contents, right? The write permissions, when applied to the directories, allows entries to be modified within the directory. So you can edit files that are in the directory. The execute permissions gives you the ability to see metadata about the files that are in the directory. In previously we executed one command, right? ls space hyphen l. What it displays all the detailed information permissions along with the modification dates, right? That is the execute. There are categories of users. These read, write, and execute permissions can be applied to. These categories are user, group, and others, and all. Like permission types, each one represents a single letter. For example, U represents user who owns the file, who creates the file. The users that are in the files group are represented by G. Users that are not in the owner and not in the files and not belongs to the users, those are considered as others or all. And A is used to represent all, anything, everybody. Every user on a Linux system belongs to at least one group that is called primary group. For example, if you create one file, then it will automatically creates a default group that is called primary group. However, user can belongs to many groups also. Run groups command to see what groups you are member. You will see a list of groups to see what the user belongs to and which group the user belongs to. You can also use ID space hyphen capital G small n. It will give you the same output. Let me show it in Ubuntu system. Let me log in. When we run group command, it will display the groups. Vasundhara is one group and ADM is one group and CDROM. These are all the groups. If we run ID space capital GN, then it will give you the same output the same. You can use what as per your requirements, you can use whatever you need. And if you want to see the groups by username, you can give groups. Let me show. Here we have Vasu, right? Let me see this Vasu is belongs to which group? Group. We need to give group. See, this belongs to DevOps of underscore 01 and DevOps. This this user, this Vasu is belongs to these two groups. At this point, you finally have enough background information to start the decoding. The permission string. We have covered that the first letter is a type. We have covered that first letter is a type, and remaining three characters are the permissions for the users, and next three characters are the permissions to the group, and followed by the others. So permission will always be displayed in this order: user, followed by group, and followed by others. And also read, write, execute permissions will display in this order only: read, write, and if execute permission is not allowed, then it will indicates a hyphen. Permissions are also known as, I'll show these in practical later. Permissions are also known as modes. That's why the mode you use to change permissions is called change mode, ch mode. And there are a couple of different ways to specify the mode. One is symbolic notation and other is numeric notation. To specify mode or permissions with symbolic notation, run the command chmod followed by the user, followed by user, group, and other. And an operator to add and all also, and an operator to add subtractor to the set of permissions. If, for example, if you want to add a read permission for the user, you can use this you can use these operators like u plus r, which means we are giving read permission to the user. I'll show it in practical. Let me show the files exist in this. Yeah. Under this directory, we have these files and these links and directories, which I have mentioned, which starts with D, then it considered as a directory. It starts with a hyphen, then it is a file, and which starts with L, it is a link. Now, we are going to change the permissions for this file, F2 file. I want to, for user here, we have only read and write permissions, right? So now I want to give permissions to the user, execute permission. So for that, we need to mention ch mod space. We need to give for what for user, we need to give the execute permission, right? Mention new plus x and mention the file name F2. Click on enter. Now let's see by running this ls-l command. The execute permission. Before we have only read write permission for the user, right? Now execute permission have been included for this F2 file. Right now, if you want to add for the group also, you can mention the same thing. Here we have read write permission. Sorry. Here we have read write permissions for the F3, right? If you want to give only for the group, then you can mention g plus chmod g plus execute permission and mention the file name. Let me show by running this command. ls for F3 F3, right? Yeah. For F3 group level, we have given the X permission. Now, if you want to set different permissions for different user categories, you can separate the specifications with a comma. For example, like here I have read write for user and read write for group and read for others, right? Now I want to give all execute permission for all, like chmod the user. I need to give read write execute permissions all. We need to give mention read write exit comma, and for group we need to give read write execute comma, and for others also I can give I'll give the read and write permission only. My requirement is not giving the permissions. So O means other plus read write. I mention the file name, file one. And click on enter. See, once check. Only read and write permissions are given. For user and for other for groups, we need to give the execute permissions, and for others, we have given the read and write. And click on enter. Let's see whether it has been changed or not. See, for user and for group, execute permissions are allowed, and for others, we just given the write permissions. Now, when you specify an equal sign, that sets the permissions to exactly what you specify. So let's say now I want to change the F to file permissions. All equal means which means chmod a equals to r. I need to give the only the r permission. You can give this like ls space hyphen n. The only r permissions have been changed. Previously, we have read, write, execute for users also, but it has been changed to only read. And you can by using this equal notation, you can give like this also. Chmod u equals to, I want to change f for f2 only. U equals to read, write, x, comma, group equals to read, execute, comma, others empty. And we need to mention the file f2. Click on enter. Let's see whether it has been changed or see. I have mentioned read, write, x for user and read execute for a group, and empty for, I mean, no permissions for others. And others are not allowed to view the file, view the contents in the file, and others are not allowed to modify the file, and others are not allowed to execute the file. In addition to symbolic mode, octal mode or numeric mode can be used with chmod to set file and directory permissions. In octal mode, permissions are based in binary. Each permission type is treated as a bit that is either set to off or on. Again, permissions has an order: read, write, and execute. If read, write, and execute are all set to off, then the binary operation is 0, 0, 0. If they are all set on, the binary expectation is 1, 1, 1. If you want to remove the write permission, then the binary representation would be 1, 0, 1, because we have removed the write permission, right? So the binary representation will be 1, 0, 1. To get a number that you can use with chmod, convert the binary representation into base, 10 or decimal. So really the shortcut here is to remember that read equals to, this is more shortcut when we can easily represent. For read, we have value as 4 and write equals to 2 and execute equals to 1. The permission number is determined by adding up all the values for each permission type. Here there are 8 possible ways from 0 to 7. Hence the name octal mode. The user categories are always in user group and other order. So once you determine the octal value for each category, you specify them in that order only. For example, read, write, execute for user. And execute for group and just read for others. You would specify change mode 754 space in the file name. I show. Yeah. The user categories, here we have, for example, for user, we have mentioned read, write, X. Previously, I have mentioned some values, right? Read means 4, write means 2, and execute means 1. So by summing up all these values, we'll get the user group. If they mention user permission as 7, which means the user has all the permissions: read permission, write permission, execute permission. Here for group they have mentioned only read and write, which means 4 and 1. 4 plus 1, 5. So we need to mention it as a value as 5. Now for let us assume these all the permissions belongs to file 1. So 754 are the permissions for the file 1. Here are the most commonly used file names. So 700 ensures that a file can be read, write, and execute by this owner, by the user, and no one else on the system will have the access. For our groups and for others also, no, don't have any access to write or read or execute. For 755, permissions allow everyone on the system to to execute the file, but only the user or the owner of the file can edit the file, because they have mentioned the right. For our groups and for others, they haven't mentioned the right permissions. 664 allows a group of people to modify the file and other has read. See here they have mentioned write permission and others no. And for 660 also, for users or the owner of the file and the group had a read and write permissions and others don't have any permissions. And for all the people don't have any execute permissions. And for 664 allows everyone on the system to read the file, but only the user or the owner of the file can edit the file. If you are ever tempted to use 777, means 777 or 666 for permissions, ask yourself if there is a better way to do that, because giving 777 permissions gives everyone on the system full access to that file or a directory. If you give all the permissions, if you give all the access to others also, it will lead to some troubles. If you really want to give access to multiple people, consider using the groups and adding the particular people, adding the limited people to that group, and you can use them limitedly. In general, it's good to avoid the 777 and 666 permissions for better security. We'll discuss more things about these directories and file permissions in the next lesson.